Hello everyone. This video is to demonstrate the distortion that is experienced by the signal when the signal is exposed to noise. When the signal is exposed to noise. As you know, signal while it is transmitted either through the wire or in the wireless means, it will definitely experience or expose to different kinds of noise. And this is what we wanted to study. For this purpose, I will be using MATLAB, specifically Simulink, which is part of the MATLAB. So, there are three objectives. First one is to introduce the Simulink software. Then, using the Simulink software, we will create a model which will show us how the signal is being affected by the noise, how the signal gets distorted because of the noise. So investigate the signal distortion, and also we need to find a solution for that. So we cannot completely eliminate noise. Noise will be there for various reasons. So at the receiving end, when you receive the signal which is distorted because of the noise, we need to have a solution so that it will separate noise from the signal. So these are the three objectives. So introduce Simulink, then investigate signal distortion, and investigate signal filtration. What is Simulink? It is a software package for modeling, simulating, and analyzing dynamic systems. In our example, we'll create a small model where we will have a source for generating a signal. In our case, we'll create a very simple sine wave generator. And we also will have another source which will generate random signals. So this behavior of this random signal we can equate to noise. Random means at any point in time we cannot predict the values. However, we can say this random signal will be between so and so limit, between 0 and 1 amplitude, or it will be -1 to +1 in terms of amplitude. So a random source, we can use it to compare a noise. Then we will add this noise to the signal and see what happens to the noise, what happens to the signal when it is added with the noise. This is what happens when the signal, when it is exposed to noise. The noise will interact with the signal or original signal and will create some kind of a distortion. So a model like this will help us to find out the effect of noise on the signal. So first of all, let me show you how you can access the Simulink software. What we'll be doing is we'll be accessing our university Citrix server. From there, we'll be launching the MATLAB, and from the MATLAB, we'll start Simulink software. To start with, visit the site store.uaeu.ac.ae. Right. You can use your university ID and the password to log in. So we'll be starting the MATLAB first. A small file will be downloaded. Click over the file here. Right. So this is the MATLAB software. So from here you can start the Simulink either by clicking over here, or you can type the command Simulink. So this is the first page. When you launch Simulink, here we'll create a blank model. Click on a blank model. Let me save the file first of all. I'm going to save it in my local drive. All right. So let me give a name. Signal distortion. Give a relevant name. So here you can see this particular icon. This is a library browser. In the library browser, we can use the blocks that is required in our model. In our case, we want a source that will generate a simple sine wave, and also another source that will generate random signals, which we'll use it as a noise. Then we'll need another block called sum that will add the noise to the signal. So let me click over here. It will present a lots of blocks. It will open the library browser and we can select the blocks that we need. We'll go to DSP system toolbox, go to sources and select a sine wave generator. This is the first block we are going to use. You can click, drag and drop. Now other sources that we need is the random source. And the third one is add or sum. So we'll go to Simulink, commonly used blocks. Here you can see a block called sum. Click, add and drop. Now there are two inputs to the sum. Our sine wave output will be given to the first input. and the output from the random source will be connected to the second input. So this particular model will represent effect of noise onto the signal. The output from the sum will show us how the signal is being affected by the noise. Another block that is going to help us is a scope. Scope is available in the sync. We'll use time scope. We can use the scope to see the signal and also the noise and also the output from the sum. So you can have multiple copies of this scope simply by, you can either copy and paste or press Ctrl and right click and drag. I'll have 3 copies of this one. The first one I will use to see our original sine wave. The second one we'll use to see the effect of noise on the signal, and the third one we will see the noise itself. Before we do the simulation, we need to define our signal. In our case, when you click on this sine wave generator, you can set the amplitude, frequency and phase, all this. So I'm going to use a sine wave of amplitude 10 and the frequency of 2 Hz, and the phase I will keep it as 0, and the sampling time is 1 over 1000. The noise, what kind of noise? I'm going to set the noise always between the limit of -1 and +1. That means at any point in time, the value of this particular random signal will be between -1 and the +1 in terms of amplitude. I'm going to use the sampling time, which is same as the original source, 1 over 1000. Say OK. So what we are doing is we are adding the noise to the signal and see what kind of distortion, how it distort the original signal. So let me run the simulation for 1 second and run the simulation. Now the first scope will show us the original signal. So you have, this is the first one, time scope. This is our original signal of frequency 2. From 0 to up to here, this completes 1 cycle, and from here second cycle starts. So in 1 second, 0 to 1 second completes 2 cycles. So the frequency is 2. What about the amplitude? Amplitude is 10. Maximum jump is 10. So this is our original signal. When this signal is added with the noise, here is the noise. At any point in time, the value of this random source is between +1 and -1, and it is of very high frequency. And you can you can use the scope and you can zoom it. For example, if I want to see the signals in the noise, I'm going to use a horizontal zooming, and here horizontal, and just expand it on the time scale. So this is the noise. Right? Now when this noise is added to the signal, this is what happens to the signal. For example, for the actual signal, value over here is 10, and here what we expect is 10, but because of the noise, when the value should be 10, it could be either 11 or 9. You can again zoom it here. See the value? It's supposed to be 10, but it's not 10. It is between 11 and 9 at any point, right? So this is how the signal noise affects the signal. Now, what happens if the noise level is more? Let's do that again. Let's change the value. Instead of -1 and +1, let me put a noise value of -5 and +5. Run the simulation again. Look what happened to this noise, happened to the signal. So here, what we are demonstrating is, what we are trying to investigate is, what happens if the noise level is too much. So when this kind of when the signals are exposed to this kind of noise, it is very difficult to retrieve the original signal. Right? So what we try to do is we always try to minimize the noise. Right? Then at the receiving end, we will separate the noise from the signal. So we will go back, we will set it again and reduce the noise level to -1 and +1. Now we'll see how we can save the signal from the noise at the receiving end. In order for that, we'll use a block set called filter, which is again available in the DSP system toolbox. You can see filtering. There are filter implementations, and take digital filter design. Now, input for this filter design will be the output from the sum. And we'll use one more scope, control, right click and drag. And we'll connect the output from the filter to the scope. Now, before we run the simulation, we have to do some kind of setup. Here, as you know, the signal is of low frequency and the noise is of very high frequency. So we need to design the filter in such a way that this filter will allow the low end of the frequencies to pass through and block the high frequencies. So for this, we'll design this as a low pass filter. Double click on this one, and there are different kinds of filters available: low pass filter, high pass filter, band pass filter, band stop filter. But what we need is a low pass filter. So select low pass filter. And the next, select the unit to be of hertz. So what we are going to pass all the frequencies up to 1000 hertz. And beyond 1000 it will start blocking the high frequencies, and by the time it reaches 1500, it's going to completely block all the high frequency signals. So 4 parameters: low pass filter, select the unit to be in hertz, then f pass is 1000 and f stop 1500. Design the filter. When you see this message done, designing filter done, you can see, you can close it. Now, what we expect the output of this filter design, we expect our original signal back here and without any noise. Let's simulate it again. Run the simulation for 1 second. Here it is 1 second, and run it here. Our time scope 3 should show us the original signal here. So this is the output from the filter. and this was the input to the filter. So what the filter did is, filter blocked the noise part from here and allow only the high frequency, only the low frequency to pass through, which was our original signal. Right? Now what you can do is you can try different parameters. You can change the values of the original signal. You can change the values of the noise and see what is output at different conditions, as explained in the document, in the lab document. All right. I hope this demonstration is helpful. So complete the assignment. Thank you.